This meeting is being recorded.
Hi, everyone. Welcome.
That's new.
Yeah, that's new. She's announcing it. Aaron Smith with EBA. Welcome to the EBA webinar podcast series. I'm joined as always by Nancy Bakeman, and we're really excited to bring you a session on heat pump water heaters. Many of you saw the videos. I put one in my house to test it out. We've had lots of builders across the country, across North America, that are really interested in this great technology. So we've put together some of the top experts in the country today. I'm always pleased to be joined by Dean Gamble. Dean is the EPA Energy Star Certified Home Programs Leader. We have Nate Jutras with the EPA Energy Star Program and the resident heat pump water heater expert. We've got Greg Holliday from Bradford White. Greg has done extensive training across North America and has the best mustache in the business. And then finally, we're joined by John Miles of Eco2 Systems LLC as well. So standard webinar applies. We'll have the Q&A section at the bottom of the screen. I think because we have 4 speakers today, if you're putting questions in the Q&A, we may be able to type answers to those in live, but I will present your questions to our guests. And with that, Nate, I'll turn it over to you.
Great. Thank you, Aaron. Okay, well, thank you. Thanks. So today we will be tackling heat pump water heating, as Aaron said, and Energy Star heat pump water heaters, also referred to sometimes as hybrid water heating, although there is some difference, and we'll get into some of the nuance there. They're not exactly interchangeable, but pretty close. A lot of what Energy Star does is, especially in water heating for heat pump water heaters, is dealing with introducing it to both the consumer and to the implementers and utility programs, in part because it is such a powerful tool for savings. And I like to compare it, especially when I'm talking with utility programs, to the LED light, which utility programs have really taken advantage of and introducing and subsidizing and really kind of flooding the market and lowering the cost. I'm sure everyone on this webinar is well versed in the savings that LEDs has brought us. Well, heat pump water heater is sort of the next progression in utility programs, and also in terms of what I think we'll see in terms of code changes and incentives that hopefully builders will get from utilities. It's about 4 times more efficient than a standard electric model. $2,300 to $3,400 kilowatt hours saved per household. Roughly like changing 75 to 90 light bulbs from incandescent to LED. That's a family of 4 can save about $425 a year compared to an electric resistance water heater. And similar to an LED, it has a much longer lifespan than your electric resistance. And also, I think it's worth mentioning that the homeowner is going to get a longer lifespan out of it than a tankless. There's a lot less maintenance required. The payoff is very quick. It is a more expensive product at this time, but the payoff is really quick, and it varies. It varies, and I'm talking to someone in the Northeast the other day, and their kilowatts, you're talking about 24, 25 cents kilowatt hour, and that $425 is actually closer to $800 per household saved a year. That's eye-popping. But there are some differences, of course. It's a heat pump water heater is it's changing one out is not like changing a light bulb. For one thing, you only change it about once every 12 years or so. So when we're talking to utility programs, it's trying to get that emergency replacement is difficult. And we like to point out that if you one of the best ways to get savings is from new construction. And we're encouraging that as much as possible, because the difference between the cost of installing something else, whether it's electric resistance or tankless, and a heat pump water heater, it's not that great. And we can get into kind of the dollars and cents of it later, but new construction is where we see a great opportunity. And I'm going to speed through a little bit of this because I want to, I think some of my fellow presenters will get into installation and some of the nuance there. But just a couple overarching facts about the heat pump water heater market. It's roughly only about 2% of the electric storage market, but it is growing quickly, and it is very regionalized. So in the state of Maine and parts of the Pacific Northwest, it is double digits. The state of Maine actually sells more electric heat pump water heaters than electric resistance, and Oregon as well, 20%. And California, which is a 95% gas water heating, has a target of installing 6 million heat pump water heaters by 2030. There's movement in terms of new manufacturers getting in. There's a lot of palpable excitement about the technology and new products being offered. Energy Star sets it's a voluntary program, as I think you all know, both from the building program as well as products from your TVs to your dishwashers and refrigerators to heat pump water heaters. And just this past January, we updated our specifications, and there's one specification for your integrated heat pump water heater, which is Greg will touch on, and then a separate one for split systems, which John will talk about. And there is also a 120 volt system that will be coming on the market that is targeted. I actually don't think it's worth getting into here, because it's more of a I don't see it as a product that will be particularly popular with builders. It's more of a replacement for retrofit for gas systems. Just a couple some of the savings numbers. You'll notice the over 55 gallon numbers are lower because the DOE minimum standard for an over 55 gallon within the residential, you can buy a commercial one that's you can buy an 80 gallon commercial one that's electric resistance, but the DOE minimum standard for electric resistance, I'm sorry, for electric storage is actually a heat pump water heater. And lastly, I'll just put a quick plug in for one of Energy Star's best resources, which is the Energy Star Heat Pump Water Heater Manufacturer Action Council, or SMAC for short. And we put this organization together a couple of years ago, and it really just brings the resources of the manufacturers together and lets us pool our resources and really kind of get the word out about the technology, provide training, which is really needed. There's many parts of the country where still, if you called a plumber, they might not know what a heat pump water heater is, which is, we hope to change very quickly. So I'll just end it right here and want to hand it off to my friend Greg Holliday from Bradford White. Greg, please carry it away.
Excellent. Thank you very much, Nate. One moment, let me pop up my screen here. Here we go. Welcome to my farm in Kentucky. You're now on 22.5 acres of some of the prettiest land where the grass on some days, depending on how much of one of the main products we have in Kentucky you consume, does have a little bit of a blue tint to it if you look at it just right. Right now it's a little green and probably a little more brown because we need a little bit more rain to get the crops going. But welcome to Kentucky. I'm Greg Holliday with Bradford White. Let me get my screens to be able to pop here. Hang on. Wouldn't you know it? You get one more thing going. Bear with me just one second. This is the technology challenge of the day. There we go. Now let's get this going.
Perfect.
My job, what I do and what I have been doing for 13 years is educating builders, contractors, utilities. As the first guy that was actually out there representing a heat pump water heater, a Unitized model that I introduced for General Electric in my 32-year career there back in 2009 as the first ever Energy Star heat pump water heater. So my job has been, and I stuck with that even when we private labeled this for Bradford White and GE decided to get out of the heat pump water heater business briefly when they were purchased by High Air. And Bradford White bought the plant, hired me, and we continued to build the only American-made heat pump water heater. What I'm going to give you is an overview of the market and things that have happened since I was there at the very beginning when this all started and have been with this type of a product for these last 13 years. So I'm going to speak a lot generically about what's going on in the industry and how different manufacturers have taken different approaches to building these products and being able to put them out there. Tell you the things that you're really going to need to know, which is how do they work? Why would a builder want to put one of these into a house? What requirements might there be in the industry? But really, more or less, what's the big deal about a heat pump water heater? How do they work? What's the best place to put them? What are the service requirements and what type of after sales support should you expect from a manufacturer? So I'm going to say a lot of things generically, but you're going to see some of the images of my product as we kind of go through that because you got to see something when you do this. So where it all began was way back in 2009 when Energy Star rated the first ever heat pump water heater that happened to be a GE Geospring. But Energy Star, that message goes all the way back to 1992 when greenhouse gas emissions became a hot topic and the whole Energy Star brand was created to encourage manufacturers to build products that use less energy, that are more environmentally friendly. And it started with some computers, but then it quickly went to the highest energy user in the home, which was the HVAC system. And the HVAC industry has been Energy Star influenced for all that time since 1995. When the first HVAC product came out, it was more efficient than anything else that was previously made. And then a few years later, they raised the bar and it got better. And they raised the bar again and it got better. And they raised the bar. And now we're at higher SEER ratings than we probably would have ever achieved if there hadn't been some of that pressure on that industry. But water heating was the second highest energy user in the home. And when they went to the water heating side of the equation, manufacturers at that time said, we really don't know how to build something that's more efficient than what we make today, because they were tanks of water with either a gas burner underneath blowing 45,000 BTUs of heat into the tank, or heating elements in the tank, 4,500 watts, directly heating the water. So the only thing that really could be done to enhance that was to better insulate the tanks, which did happen in 2015. But it took a manufacturer of heat pumps, and we call those heat pumps refrigerators to GE, to say, we've got a different idea on how to do this, and other companies have tried, but GE built just a few million refrigerators during that time and said, this is pretty simple principle of being able to adapt the ability to move heat to a tank and also to be able to create heat so that you provide the same volume of hot water as a standard electric water heater, but you do it at a 70% energy savings. Now, why did they target that? Because 50% of the country has electric water heaters. That's what most of us grew up on, most of us in the country at least, because you don't have gas water heaters out here where there is no gas infrastructure. You either pay for propane or you put an electric water heater in. Nobody ever knew that this was all going to turn into not just a replacement for the 50% of the market that has electric water heaters, but also turn into the replacement for the market that has gas water heaters. And it goes back to that same Energy Star message, greenhouse gas emission reduction. So this uses 3,000 less kilowatt hours in general for all manufacturers' products, and they provide the same volume of hot water. The difference is they have a longer warranty, and by definition are the only form of heating water that pays for itself through energy savings alone. And when I say pays for itself, I mean pays for the tank, the installation, everything, as compared to a standard electric water heater. It uses 3,000 less kilowatt hours. That equals about a $300 a year savings or more, depending on how many people are in the house. And with a 10-year warranty for the homeowner, they're going to offset that cost with a savings of about $3,000 to $4,000 over the guaranteed 10-year life. That is a really big deal. When you're taking the second highest energy user in the home and you're cutting that much energy cost out, I have to ask you as a builder, what could you do that would be more significant at this point? You're already doing better insulation things. Now we're talking about and better windows, and you're doing better HVAC. Let's tackle that second highest energy user. So I want you to understand some of the terminology, because we're going to talk about several things today with different presenters. Heat pump water heaters are also known as HPWH, hybrid electric heat pump water heaters. Lots of different names that you'll see to it. Sometimes they say they're electric, sometimes they don't, but generically a heat pump water heater is going to typically have a heating element and also have a heat pump until you get to the 120 volt models, and some of those will only be heat pump. But they're unitized, meaning they're all one piece. They sit in the same space essentially that a standard electric water heater goes. They use a 30 amp service for the water heater itself, and they're 220 volt, and they size exactly the same as a standard electric. Then there are going to be some split systems that you'll see as well. Split system is going to have one part of the unit outside and another part of the unit inside, and those units will operate at lower ambient air temperatures because part of that system is outside. The other water heaters are designed to be used in the house, which is where water heaters have always been. So you don't have to worry as much about the weather. And sometimes that's part of the myths that'll be in the market is, well, where will they work? Can I use them in a northern climate? Yeah, and I tell people that all the time. You can. I'm a Kentucky boy. We put our water heaters in the house. And if you go to Minneapolis, I'm pretty sure they put the water heaters in the house there as well. So as long as it's in the house, it's not in a freezing environment in spite of what's going on outside. And as Nate already noted, the #1 state of installations for heat pump water heaters is the state of Maine. Doesn't get much colder than Maine when you get up there in December and January, and I know because I've been there during that time. So you're going to see operating modes for all of these manufacturers, 4 typical operating modes. You can use heat pump only. So if you've got a solar application, a heat pump that uses only 500, 600 watts of power, 400 to 600 is what they typically run, can be used in the heat pump only mode on a solar panel. The hybrid mode, which is where it's Energy Star tested for each manufacturer, is when it uses the heat pump as the primary means, but also can switch to resistance heat, therefore providing exactly the same volume of water as the standard electric 50, 65, or 80 gallon water heater that it replaces. So it's not spec'd any different. It doesn't have to be any bigger for that. It's the same thing, and that's where the savings is measured. You also have an electric only mode on each of these products. That's primarily there as a backup. So if anything ever happens to the heat pump side, these are dual function water heaters, the first ever. It says I can switch from heat pump to resistance heat if something happens there. I can switch to resistance heat from heat pump if something happens on that side. So it takes something pretty catastrophic for the water heater to produce no hot water. And then they also have vacation mode. So if you're going to be gone, you can tell the water heater, don't run when I'm not at home. Let's just switch this thing off. And that way I don't have to use any energy. Let's talk about some installation considerations. Everybody will always ask, what about a mixing valve? Can I put a mixing valve on a heat pump water heater? Well, you can. A mixing valve that's properly used will allow you to turn the tank temperature up to the 140 maximum setting. Now you've got real hot water that's going to mix with cool water that you're going to use in a shower typically, but it's going to mix right there at the tank. And that way you use less hot water and more cool water to balance it out to a desirable temperature when you take a shower. So it can make a 50 or a 65 or an 80-gallon water heater act like a larger tank simply because you're using hotter water. You got dedicated 30 amp service, which we've already talked about. Recirculation pumps, those are very popular as well because sometimes water heaters are not centrally located in the house where your showers are. Instead, it's 70 feet over on one side and the master bath is way over here. So in order to have hot water coming out of that tap quickly, you put a recirc pump in that says, a smart pump that says, I'm either going to recirc because there is a sensor in that bathroom, and when that master bath is accessed, I'm going to motion detect, recirc, or I'm going to have a button that somebody pushes, or I'm going to have a timer on that recirc system that says this homeowner gets up at 6 o'clock and takes showers in the morning. At 5 minutes or 10 minutes to 6, we're going to recirc that line, dump all the cold water out that's been sitting all night, recharge that hot water line with hot water so that they don't waste water getting ready in the shower. You do not want to try to put on a system that says, I've just got a pump that's going to keep the lines charged with 120-degree water 24 hours a day. No manufacturer will allow or support that because that means the water heater is going to run all the time. And somebody's going to say, why is that water heater running? Because it's continuing to reheat that same water over and over again. And that's not a good point to have. Installation considerations. Installing it with photovoltaic panels, it only draws somewhere between 400 and 600 watts of power. So they are solar friendly, makes them very easy to use. Every manufacturer is now in line with and has been in line with the Connect Plus ports on the water heaters to allow them to be CTA 2045 compatible. That's for utility use, so that a utility could send a signal if there's a load control program, and every manufacturer has already stepped up to the plate to have that. So in California, there are some requirements in other states to be able to include some of those things. Expect manufacturers, again, each of the major manufacturers to be able to do that. These products also have to have a 10-year warranty. A standard warranty on a water heater is 6. These have 10 years on the tank. On all the parts, compressor, condenser, evaporator, heating elements, everything 10 years in parts, 1 year in home labor. Consult each manufacturer for different points of that. Some water heaters are replaced if something happens with a sealed system. Others, like mine, are 100% repairable in the home, just like your refrigerator. And you're going to hear me remind you of that. You've got 3 or 4 heat pumps in your house already. And it's very simple to be able to see that if you think about it. It's called a refrigerator. Refrigerators in your kitchen and in your garage, they don't make food cold. What they actually do is they make food less warm. Refrigerators say if you put a hot pot of chili inside, the refrigerator is going to extract that heat. And where is it going to put it? It's going to put it on with your feet in the floor under the front of the refrigerator where there's a condenser coil and a fan behind it. And it continually blows warm air into your kitchen because refrigerators run about 70% of the time. Now, a refrigerator costs somewhere between $60 and $80 a year to run because it runs 20 or 70% of the time because somebody's always opening and closing the door, letting warm air in, and it says, now I got to do that again. Well, those same components are attached to a heat pump water heater that says, when somebody starts taking a shower and I push cold water in to get warm water out, that the water heater turns on the heat pump first. And it says, I'm going to start pulling air across the evaporator. And that's going to be air that's above 35, 40 degrees, whatever it is in the house, in the basement, in the garage, in the laundry room, wherever the water heater is located. They're tested at 68 degrees because that is the average temperature. But it pulls that warm air across the evaporator, attaches that heat to the 134A. It then compresses that gas to boil it and releases the heat by wrapping a hot condenser around the outside of the tank. Why does it do that? Because if we don't touch the water, we don't have to descale anything. So it's pressed into the side of the tank. It's then covered with about 2 inches of non-CFC high density foam, which creates an R19 energy blanket. And this water heater that you're seeing here only loses about 5 degrees in 10 hours. So that means it doesn't run essentially when you're not at home. Now, it has backup heating elements in it because most every house has a 13-year-old that says, my job in life, I swear to God, every day is to use every drop of hot water there is whenever I jump in the shower. So the water heater says, I'm going to primarily use the heat pump. And if you take 1 or 2 showers, sometimes even 3, depending on the volume of hot water that you have, then it says the heat pump may be able to take care of that recovery altogether. But if Junior gets in and drains the tank, now the water heater says I'm going to use the heat pump as long as I can until I determine with the algorithm that I'm running, measuring ambient temperature, tank temperature, and how this transaction of heat is occurring. At some point, it says he ain't going to get out. I'm going to flip from heat pump to resistance heat, and I'm going to recover just like a standard electric water heater does, because it is indeed a standard electric water heater with 2 heating elements in it. So in this case, with my water heater, it's going to turn off the heat pump, bring on the upper heating element, just like a standard electric. It's going to recover the top 30% of the tank. Then it's going to turn off the upper heating element, go to the bottom heating element, bring it on with the heat pump. And now you're going to be able to recover the bottom 60 to 70% of the tank. And then it turns itself off and says, I'm ready to do that all over again. When it does this, this is going to save that homeowner about 3,000 kilowatt hours a year. Now, put this in perspective. When a heat pump water heater is running, it's about the equivalent of 550 watts of power. That's 5.5 100-watt light bulbs. That's it. 5.5 100-watt light bulbs. When standard electric heating elements come on, they're 4,500 watts. That's 45 100-watt light bulbs. That's the difference in using the heat pump to move heat versus resistance heat to create heat. In the hybrid mode, where it's Energy Star tested and where the energy labels are printed, energy guides that are on this product will only cost you about $115 a year, 3,000 less kilowatt hours. If you put them in heat pump only, you save even more, but manufacturers don't go to the trouble to actually test them and give you a specific number. But you got to ask yourself, if it's $115 a year, how much more can I squeeze out of it? You do get some. But in the hybrid mode, the promise is this: it will provide exactly the same volume of hot water as the standard electric water heater that could be in that house, and it's going to do it at a 70% energy savings. So that's a really big deal because it takes the gamble away. Now, I mentioned something about payback. Payback is a pretty simple equation to look at. A product that is less than 100% efficient can never pay for itself because it loses money every time it turns on. Well, every water heater that is out there that is not a heat pump water heater is less than 100% efficient. So a standard gas water heater, the UEF, Universal Energy Factor, that it's rated with by the DOE, says that it's got a 0.60 UEF. That means it loses about 40 cents of every dollar you spend to heat water. You look at a standard electric tank, that's a 0.93, much better, much more efficient than a standard gas tank. But electricity is more expensive, so the energy guide makes it look like it's not as good because electricity's cost more. So some people go to a tankless like California did, 0.82 to 0.97. These are great water heaters because they never run out of hot water, but they cannot pay for themselves through energy savings alone, because every time they turn on, they're using or providing less than $1 in hot water for every $1 you spend. Now, when you look at a heat pump water heater, because it moves heat, you're talking about a UEF that's, in this case, a 3.39 for my product. Some are up to 4.0. That means for every $1 you spend to heat water, you're getting over $3 in actual hot water. That's the win. That's what a homeowner wants to hear, is that the water heater that's in the house isn't just high efficiency. It's the highest efficiency. It's the water heater that pays for itself by giving you more than it takes. So that really is the message, and that's proved by looking at the energy guides that you see on the screen now. A standard electric water heater, $419 a year. A heat pump water heater, about $115, some are even less. And you can see the energy guides for the 65 and the 80, as well as some comparison with a gas tank water heater on the bottom left, and a gas tank water heater or tankless water heater that's a 0.90 versus a heat pump water heater. The numbers don't lie. That's what it is. That's the difference in efficiency and so on. Here are the top manufacturers' brands for Unitized products. You see Rheem under the names of Rheem, Root, and Richmond, and they have a few series listings here that they provide through both retail and through contractor sales. You've got A.O. Smith on the far right, with A.O. Smith, American, Craftsman, Lochinvar, several names that they market under. And then you've got Bradford White in the middle. We happen to be the only manufacturer that builds a heat pump water heater in the United States and does not sell in retail. So my product is only available through plumbing contractors through the professional grade of being able to purchase it that way. You'll also see some differences in the connections. The Bradford White is a top connection water heater. The others are going to be side connections, and a little difference in the serviceability. You'll see that Rheem pretty much leads that portion of it with the higher UEF, which takes that down to $104 a year compared to $115 and $114 for Bradford White and A.O. Smith. So the higher UEF does help, but it is proportionate to the savings that you're going to provide, which is about $8 or $10 a year, depending on which manufacturer that you're comparing. And you'll also see some differences in the venting, which we'll talk about in a minute. So where do you put these things? You put them in the basement where a water heater goes today. You put them in a laundry room in the house because that's where a heat producer is, a dryer and a moisture producer. And you've got a water heater that says, I love that because I dehumidify up to 2 quarts of moisture a day wherever you put me. So if you put me where there's warmth that makes the laundry room the warmest room of the house, I'm going to benefit you by being able to make that a better room. But you put it in a closet where you, if you need to, where you've got a louver door, and you get a little bit more space out of that portion of it by allowing it to breathe into a larger room. So what's the same as a standard electric is the volume of hot water that it provides. The first hour rating, which any plumbing contractor is used to looking at, is the same. If you're replacing a gas water heater, the sizing of an electric water heater is different than the sizing of a gas water heater. A 50-gallon gas water heater puts out more hot water than a 50-gallon electric because it's got a 45,000 BTU blowtorch sitting underneath of it, whereas the electric water heaters all have a 30 amp limitation, so they can only provide so much heat. So you size it properly by following the electric side of that, and I would encourage you to get with the manufacturers on their websites. We all have some sizing charts on there that will help a contractor understand you're following standard electric sizing, but we emphasize that by showing them the heat pumps for it. It can be put in a basement, a garage, a utility room, an attic. They have 3/4 inch connections. Ours happen to be on the side, A.O. Smith and Rheem on the top, A.O. Smith and Rheem on the side. They have standard electric heating elements and T&P valves, just like everything else that you've been using in the past. What's different is that these water heaters need air, about 700 cubic feet of air. That's a 10 by 10 by 7 room, or a closet with a louver door, as you see in that picture, top to bottom, that breathes into a larger room. That allows it to be able to get the air exchanges. 7 inches around each water heater. And I spend a lot of time working with builders to be able to emphasize this. Putting them in the right space is critical. Getting your designers to do it now is critical, because you'll avert a disaster next year when you start trying to shove it into a spot and you say, wow, we sized that for a standard water heater, and standard water heaters don't exist anymore. Heat pump water heaters need more space. 7 inches gives you serviceability. It also anticipates in the future that water heaters are going to continue to change, and you want to make sure you don't jam it in someplace where the newest thing that comes out 10, 15 years from now will not fit. So look at the manufacturer's installation instructions and consult on that. A condensate drain. Yes.
Greg, just a quick question from the audience. Would it work to place a heat pump water heater in a crawl space where the walls are insulated, but the ceiling floor of the home is not insulated?
This must be in the Carolinas. It's the only place I've ever seen that happen before, where let's dig a water heater in the ground underneath. As long as a heat pump water heater is protected, generically, I'm going to say this, from the environment, if you can get it in and you can get it out for service, then yes, it can be. It just needs air that is going to be above 35 degrees for my product, 40 degrees for my competitors' products.
And so it's Bozeman, Greg.
Bozeman, Montana. Oh, I should have known that. Bunker country.
Yeah.
Love that. You can, again, as long as it's protected, as long as it's got enough volume of air to be able to make air exchanges. And then you've got to have a way of being able to dispose of that condensate water that it's going to collect when there's any humidity in the air. So we can talk more about that at the end if we need to.
Thanks, Greg.
The only point of maintenance for any manufacturer on these is filter. And the water heater itself is going to tell you with each manufacturer when the filter needs to be clean. It's going to set off an alarm. It's going to make a sound. It's also going to blink a light on the front. If you have the app from any manufacturer on their phone, because they're using the communication device that's been added to the water heater, then it's going to tell them on the phone as well. So that can make it a little bit easier to be able to know when to do that. You see examples of where the condensate drain is on my product. It's on the right-hand side. There's two there. One is the main condensate, and the other one is an overflow that says if that's dripping into the pan under the water heater, that tells you the main condensate is clogged with something. And that way you know to have that cleaned out with the contractor. Typical installations can look like this. These are some shots that I took right out of the Bradford White installation instruction, which is set up just like a standard electric water heater would be, other than the condensate drain. And then you see Ream and A.O. Smith, the shots right out of their books as well. The side connections do add some nuances to it that you want to make sure you pay attention to, and also paying attention to their spacing requirements and the need for an anti-siphon valve on a side connection water heater. Clearances that we as manufacturers list are recommendations for new construction, and then you'll see smaller clearances that can be used for replacement. You don't want to build new construction to the smallest dimension. You know, when we say that a water heater has a 0 clearance and you can put it up against the wall like you see in my picture right there, I'll tell you that you can do that and that it will work. But what I'm also going to tell you is that if something happens to it, it's very likely that a contractor will have to drain it, uninstall it, make a repair, and put it back in, because it's kind of hard to work on something that's pushed right up against the wall. Sometimes it's hard to take the top off of it or get to the part that you need. So just like an HVAC system, you got to have access to parts and pieces to be able to maintain it. Those constricted dimensions are for existing construction where you're trying to fit something in because this is what you got to use, and you're going to do whatever you have to do to make that happen. So follow the spacing requirements. Venting. This is a big deal in the market right now, and I hear more builders talking about this. Heat pump water heaters are all ventable, but they don't typically ever get vented. The Northwest Energy Efficiency Alliance, NEA, many years ago, and I used to attend the conferences, thought they were going to create a standard that says we're going to have a tier that says you got to vent a heat pump water heater. And they spent a year doing a field test study with 2 test homes and essentially proved at the end of that it really wasn't worth venting a heat pump water heater. Why would they want to vent it? Because a heat pump water heater off-gases air that will make a 700 cubic foot space, that 10 by 10 by 7 room it's in, 3 to 5 degrees cooler when it runs. So I want you to remember, heat pump water heaters only run when you're doing one thing, using hot water. And when they run, they don't run all day. They run for maybe 2 or 3 hours in the morning. They don't run all day if you're not home. And they might run 3 to 5 hours in the afternoon and evening because you're using it on and off as you're there in the house. So it's not like you're putting an air conditioner in the house, and there's a misconception in the market that really is what it is, and it's not. But think about where you put the water heaters in the house. If you put them in a basement, that's an unconditioned space in a conditioned home envelope where the water heater says, I'm using that free heat that's coming from the dirt outside that concrete wall, and it's able to convert that to heat. So don't think you have to put a vent on any of these heat pump water heaters. If you think you do, I urge you to consult with the manufacturer to verify, because I can tell you in 13 years of doing this, very few projects ever really need to be vented. You're getting to look into the Bradford White plant in Middleville, Michigan, where this product is manufactured and distributed from anywhere in the United States. Just wanted you to be able to see that. Some common myths, we've talked about this. Some people will say they don't make enough hot water. Well, they make the same hot water as a standard electric because they switch back and forth from heat pump. Unless you've got it in the heat pump only mode. And if you came and looked at mine here in Kentucky, mine right now are in heat pump only, because it's just me and my wife, and we don't take showers in the morning and empty a tank and say, wow, that was so much fun, let's go do that again, and now I don't have hot water. No, we take showers. My tanks are properly sized. I don't use it up unless there's company in the house, and it takes many people to make that happen. And then at that point, I'm going to put it back in the hybrid mode, and I'm going to let it switch and do its thing like it's supposed to. Some can say they're challenging to install. No, they have the same connections for a top connection for mine, but there may be side connections on another manufacturer. But in new construction, you can put either one of those in. Or they'll say they won't work in cold climates, and that's when I remind them that water heaters go in the house, not outside. So it doesn't matter if it's 0 outside if your water heater is inside the home. So they'll still work. Or they'll say they make a lot of noise, and they really don't. A heat pump water heater sounds about like a dishwasher in your kitchen. Now, I can tell you mine is tested at 55 decibels of sound, and it's because this one was measured following the protocol for appliances, and GE initiated that by putting it in the same test chamber that a vent hood in the kitchen or a dishwasher is put in, which means it's a set size test chamber. Microphones follow the protocol for the appliance industry as to how far away they are from the product in order to have a repeatable, measurable sound comparison with other manufacturers. There is no sound protocol for the water heating industry, though. So when I tell you that this one is 55 dB, it's as measured against other appliances in the house. So just want you to understand that sometimes these numbers are not comparable in this side of the industry. Some people say they won't work in a garage. Well, if a water heater in a garage is not freezing today because it stays above the freezing temperature, this will work there the same way. It's just going to have lower efficiency in the wintertime because the temperature is cooler, but it's going to have much higher efficiency in the summertime because your garage is not air conditioned, which means when it's over 68 ambient temperature degrees, it's going to be higher than the efficiency stated as a result. Condensate drains do not work in the wintertime because there is no humidity that is being removed, so there is no condensate drain. And some will say, well, I'm not a refrigeration technician, how can I install these? And I remind them, you didn't have to be a refrigeration technician to push that refrigerator into your kitchen and plug it into the wall. These are sealed systems from the factory. The only time anything you'd ever have to have an HVAC license is if you work on it. And I happen to have the only heat pump water heater that is 100% serviceable in the home, including the sealed system. It gets fixed just like a refrigerator. So yeah, you don't have to have that. Did it cost too much? They are more expensive. They are, but they pay for themselves. So the cost is really kind of relative. And when you're looking at a house that earns a HERS rating, this is going to give you more points than most other things you can do for the dollars that you're going to spend. The last thing is know the service procedures by manufacturer because they are a little bit different. We all provide essentially the same warranty. Bradford White is open 24 hours a day, 7 days a week. So you call the manufacturer. The manufacturer works with the plumbing contractor to take care of service. But the best thing to know about this, refrigerators have been around for a long time. You think of how many you have in your house with a compressor, condenser, and evaporator, and always ask people that one in the garage is 20 years old, 25 years old, how many times has it been serviced? And the answer is usually none. That's the reliability of that. The tanks of electric tanks, they've been around for a long time as well. Extremely reliable in how they work too. So this really isn't a new technology. It's the blending of two old technologies now married together to do exactly what they've always been doing, moving heat and holding water. That's my story, guys, and I'm sticking to it. Now I'm going to pass this on. Thank you very much.
Thanks, Greg. John.
Good day to you, everybody. Let me hit the old share screen section and Thanks to Greg for that really great presentation there on heat pump water heaters and all of the information and everything on there. And what I'm going to do is slightly alter away from the existing presentation, which was looking at the hybrid style heat pump water heater, to the one that we have sort of mentioned, and Greg mentioned also is, and also Nate earlier, in regard to the split style or split system heat pump water heater. And to be very honest, we actually still call them a heat pump water heater because there is no very specific word here in the US that I've been able to use, although you'll see me throw out what these are called elsewhere in the world as we look at this. So correct is I work for a company that is called Eco2 Systems, and we bring the Sanko 2 split heat pump water heater into the marketplace, and we'll talk about all of our little things. As you saw earlier, Greg had thrown in the where we look at versus the competition in the marketplace, because we always do look at the fact that there is 8.5 million water heaters sold here in the US. So the heat pump, whether it's a hybrid style or a split style, has a really great opportunity for it. And as I put down there, all Energy Star heat pump water heaters, way over that of the gas and electric water heaters, even the tankless, which are all below 1, and we all live way above 1. So that's a great thing for us to look at on these particular systems. So with throwing that one out, let's look at how a split heat pump is set up. Greg showed us some nice pictures of the hybrid, where you see that the fact that the unit exists as a single piece that you play with. Whenever you work with a split style heat pump water heater that is available here in the US, it is a 2-piece part or system, where the tank and the heat pump are external or independent of each other on these particular systems. So where the heat pump lives and where the tank live are completely different setups. A heat pump can live outside, and it can also live somewhat inside, although we'll discuss that a little later. And then the tank the same way that we work with and we saw earlier on these particular units. So what we'll do is we'll actually break down and look at the sort of what the indoor or the heat pump is going to give us here. So without sort of jumping and showing a huge amount of different specifications and all of these happy things on here, because it is designed to live outside of your home or building that you're putting together on here. That means that if we were to all move to, as we mentioned earlier, Minneapolis a little earlier, and we can find other places that get a little chilly in the winter, we'll have the ambient operation on these particular units of -26 Fahrenheit. So the actual unit will be quite happy to work down in those low ambient, even though it lives outside. And that's somewhat also similar to the old mini split heat pump air conditioning systems that have become popular here in the US and things like that. But we all have that ability to not worry about those particular low ambient temperatures. And then if you wanted to fast forward, and the fact that it is almost July and July the 4th here, we are going to see these systems work quite happily as the ambient temperature gets super hot outside, and those days where it's 115 degrees or even maybe a little bit warmer, depending on where you are on the West Coast or East Coast, you'll see those particular things. Then as the unit lives outside, one of the other issues that you always have with air conditioners or any other outside product that's creating heat or in our case hot water for you is the noise level. So the one thing that these systems have all been set up for, because the noise level for a split style heat pump water heater is just outside, it's not at the indoor tank, We've kept that noise level very low, and the idea behind that is so that it could actually be installed in a larger garage or something like that. In those particular areas, nobody's going, I can't hear myself because the water heater's running at 70, 80, 90 dBA. So this has got an actual dBA level of 37 degree of dBA on here. The other things that you will notice on here, again, 208, 230 volt for these particular systems. They are a 15 amp breaker. There is no electric element in these particular units, and we'll take a look at that as we move on down the way with this particular thing. The last small sort of setup, which we'll also expand on later, is the heat pump that is available here in the US marketplace. Makes some very strange or slightly warmer hot water temperatures, and this unit will make somewhere between 145 degrees Fahrenheit or 150 degree Fahrenheit hot water. So it always makes that higher hot water temperature, which obviously is going to be part of what we're looking at a little bit later on when we look at the tanks on these particular systems. So here is the basic for these style of units, 4.5 kilowatts, and that's very normal with an electric element size on these particular units. Then what you'll see is that, you know, the way that these systems are set up, and very much like the hybrid style units, where you pick the size of water tank that you need based on the usage of hot water in the home or the building. And here we can see that there are, you know, specifically 3 of these particular tank sizes, and that's very similar across there. The biggest thing that, and thanks to Greg for mentioning this earlier, is that the mixing valve, you know, is being very much led in as a use for on any water heater to control the water temperature as it goes into the faucets and fixtures and showers and all that sort of happy stuff in the home. These particular systems, whether it's any of the split style systems on here, will have to be provided with a mixing valve. And part of that, the reason for that is that these units will always make 145 or 150 degrees. There is no methodology to be able to say, I only want 120 degrees. How do I turn down the heat pump to stop me making that? These units are, you know, over the years have been set up so that they will always make this high water temperature on here, and then are used with some opportunity to either mix it or reduce that temperature within the tank of these style systems. So as you can see, you know, typically this marketplace for the split style heat pumps will be in the 40-gallon tank size, 40, 50 roughly, the 80-gallon, and then the large size for those particularly high hot water usage homes and areas that you always see with these particular systems. So how does that work out in terms of capacity for everything? And as we saw a little bit with what Greg was working on, you saw, and what Nate also showed us earlier, is that split systems nowadays have their own clause inside of the you know, DOE and the UE and the Energy Star requirements to actually qualify for the Energy Star. And that means that all split systems currently sold in North America have to have a UEF, Uniform Energy Factor, of over 2.2. And typically, most of the units that are on the marketplace at this point in time actually jump over that particular setup. And, you know, and a little bit sort of strangely, it's a little bit more dependent on the actual tank volume and things like that, and other sort of designs on these particular systems. But you can see that we are here looking at UEF levels that are you know, in that higher 3 or mid 3 area for the split systems that are on the marketplace at this time here in the US. The other thing that really changes a little bit for these particular units is because as we looked at the capacity level of a standard system that are sold here in the US, and typical for any other heat pump water heater that is a split style, is the capacity is about 4.5 kilowatts. What that does for us is, because the units make that hotter water on these particular systems, what they will do is create a little bit higher first hour rating, as we saw the first hour ratings earlier. So it just ticks that up a little bit on these particular systems, where you can see an 80-odd gallon tank on here is going to have a first hour rating of slightly higher, 115 degrees. And the reason for that, as you'll see in the schematic that we show, and I'll probably mention one more time, is that the water inside the tank is actually reduced in temperature. It gets delivered into the home, so it gives it a little bit more performance or capacity out of that particular setup. So as you can see here, and again, obviously, you know, as Energy Star now added the split style setup for their new version as it came out, it gave the split systems that are here in the US a nice little independent certification mode. So just as Greg showed us the nice manufacturing facility that they have in Michigan, we're going to say, where does this particular type of product, this split system, come from? Because, you know, it is not a US design, and it certainly isn't something that we look at and go, oh yeah, this is the way it was set up here in 1950 something or other. And this is actually, and this is where my Japanese accent is horrific, but I call it the Shizen Ribai Hitopompu Kyudaki, which Kyudaki is hot water, and what happened to it is that Q2 got switched over to Cute, and as such they are called EcoCutes in Japan and in different other sort of setups. They actually act a little differently, but they all still use that carbon dioxide refrigerant and have been around, I want to say, for the last 20-odd years, sitting around in the rural areas of Japan. The one thing that you can really see from the cartoon or setup, or even the actual production product look at, is that the tanks that they work with us are actually rectangular, as opposed to the good old cylinders that we like to have here in the US. But you can see that rectangular tank becomes the tank man, and the pump becomes the pumpu. So you can all pick which one you want to be. I certainly know which one I am, and I'm not going to tell anybody which one I picked out, because everyone will just laugh at me. So, but this is a great product in the Japanese marketplace. Has been going, as I said, for about 20 years. The marketplace is increasing over there, on there, and there are about 500,000 of these particular units sold in the Japanese marketplace, which is absolutely crazy. So one of the products that I've shown here, and certainly the only split in the current marketplace that's Energy Star approved, is manufactured in Japan, and you see the production line there working its way through you on these particular systems. And as I said before, the 2000-2001 design setup was actually done by the Japanese government, the Tokyo University, and the power companies, Tokyo University and the power companies that are out there in that particular marketplace. And as you can see, there are X amount of other manufacturers in there in the Japanese area, but are not bringing that particular product here to the US at this point in time. So that's the history and the basic setup for the split style heat pump water heater. And if you want to call it an EcoCute, I can do that for the next 10 minutes, and then I'll have to forget that before I start completely confusing everybody I ever talk to all day. So as I said, one of the biggest changes that you have with the split type heat pump water heater, and certainly the ones that we look at here in the US Energy Star approved, is that they use carbon dioxide as a refrigerant. And we all look at carbon dioxide and you think, okay, it makes my drinks fizzy, it you know, can do some other things for me. Maybe it's the dry ice that we want to see when we go to see a band or something like that. But for the products that we've looked at here, it's actually going to take and create heat and then add that or provide that to the cold water to lift that cold water temperature. And one of the other great things about the carbon dioxide, and we can go in and we can talk transcritical this and transcritical that, and about how it works and all of that happy stuff. But the thing that we tend to throw out there is that the global warming potential of this particular refrigerant is one. It's actually the actual way of setting up what the GWP needs to be for any product here in the US. Is it works its way based on the environmental issues of a pound of carbon dioxide. So as I have a pound, there is a pound of carbon dioxide in these units, has a GWP of 1, which makes it very nice and is very promoted by the natural refrigerant companies and things like that, or associations here in the US, but is a little bit different. But fortunately, one of the things that you'll see on these systems is because no one in the US really ever uses CO2 as a refrigerant for air conditioners or anything else like that, it does tend to be very much warranted and not require the installing contractor to ever open it back up again. So, but it does give us that ability and more performance, better at low ambient temperature. As you can see here, it'll go very happily drop down to -32 Celsius or to -25, 26 degrees Fahrenheit, and the environmental setup of these particular systems. So as we look at one of these units and we actually take it apart, obviously the first thing that we've seen of the drawings and the difference between us and a hybrid style unit is that the heat pump and the tank are separated. Now, how far can that separation be? How short can that separation be? I mean, certainly, we can, have the tank next to the heat pump in, 2-3 feet distance, and that can be very easily set up depending on the locations and things like that. Or you'll see that these systems, as they generate themselves into the US market, will have a 66-foot separation. And the reason we went 66 feet is obviously we took meters and quickly converted that to feet for us. But what that allows the heat pump to do is live in various different areas of the home. So you can set it up as you build that home or put that home together in an area where you want to have it nice and simply installed on these particular systems. As you can see then, the piping that goes between the two, and we'll look at the schematic of this particular system a little bit more in detail, is going to be 1/2 inch. Water piping, there's no refrigerant piping, as I mentioned before. It doesn't matter. The installing contractor knows nothing about refrigerant because he doesn't have to do any work with it, just like he doesn't have to do any work with a hybrid style unit. Mentioned before, 230 volt power. These will be a low amp draw systems on there. One of the setups is that these units will have no electric heaters in the tank, so they don't need any power for the tank on these particular systems. There's no electric energy used over there, so it reduces the size of the breaker size and it reduces the actual amp draw overall on these particular systems. And then you can see some of the values that we have on these particular units. As we look deeply inside to the unit, I think the biggest thing, as Greg showed us, the refrigerant piping wrapping around the tank on these particular systems. Obviously, with the split style unit, that there is no wrapping around of piping on the tank on these units. And what you have is a double wall heat exchanger, as the potable water from the tank draws its way out to the heat pump to get heated, and the refrigerant is literally sitting in sort of a second tube that's wrapped around the existing water tubes or water pipes that are spun as a coil inside of the unit, then create that double wall heat exchanger. As I said before, compressors, it's all inverter driven here, so the compressor speed goes up and down, which is where the noise levels come from on these particular systems. And then last but not least, all of the split style units have a separate pump that draws the water from the tank, pushes it through that heat exchanger as you see there, and then will flow that back to the tank as it gets heated on these particular systems. So they're sort of a little bit independent of themselves and what they look at on these particular units. So what I thought I'd do is, because this is rather different to what we were looking earlier with the hybrid, where everything is very put together for these particular systems, there is, as you can see here, the difference in the way that there are 4 connections now in the tank, and even though the Bradford White one has the connections to the tank on the top, the other companies may have them on the side. All of the split style systems always have to have side connections on these tanks, and the reason for that is that the tanks are designed for stratification, where the hot water is never mixed with the cold water. So as you draw hot water, say you don't want to jump in the shower, or run a sink or a faucet or whatever you want to try and do with these particular things, the unit will take that hot water at 145, 150 degrees out of the tank, pass it through the mixing valve to bring it down to 120 or whatever temperature is selected on those mixing valves, as you can adjust them to a perfect setup for the particular home, and then that will disappear off to the faucet or shower at 120 or even a little bit lower temperatures there. Gets mixed at the faucet or gets mixed at the shower head. That hot water leaving the tank will be replaced by the cold water at 45, 50 degrees, etc., coming into the bottom of the tank. That the idea behind that is not to mix that water, so that there's absolutely zero border between the two. We keep the hot at the top and the cold at the bottom on these particular style systems. As you use more cold water, eventually there is a temperature sensor in the heat pump that says, and it just gives the it's in the tank, it gives the heat pump a little, hey, I'm getting a little cold in here, will you make me some hot water please? And the heat pump goes, oh, okay, let me kick myself on. And what it has, as we saw the picture, the photograph of an external water pump in that particular unit, it's going to draw that cold water from the very bottom of the tank. It likes the fact that it's a cold water because it's going to lift it 100 odd degrees up to 145 or 150 degree Fahrenheit to put back to the top of the tank. That water drawn to it at the 20, 30, 40, whatever the length of, as long as it's approved by the manufacturer, that length of piping between the tank and the heat pump, and then it goes through what we call a gas cooler. In Japan, it's, we can call it the refrigerant hot water heat exchanger or other things, but it's called a GC, or a gas cooler, on there that takes the refrigerant, obviously moved around on the carbon dioxide side. That will launch it up to the, or heat it up to that 145, 150. That water will disappear back out of the heat pump, saying, oh, I'm nice and warm, let me go back to the top of the tank, and it heats the tank from the top down. As it does that, what the units will typically do for these types of system is, what they care about very much is what temperature is the inlet water temperature, what temperature is the inlet water to the heat pump, and what temperature is the outlet water, because all it's trying to do is ensure that the system is operating correctly. And what this system will actually do is it fills that tank from the top down now at a certain gallons per minute flow rate. Eventually that bottom of that tank will switch over from being cold to getting warmer and warmer and warmer. And then typically with these style systems, they will always cycle themselves off when the inlet water temperature is going to reach that well-known imperial setting of 126.5 degrees Fahrenheit. And if you wanted to do that in Celsius, it would work out a little easier if we all suddenly jumped and started using the Celsius numbers and the metric system on this particular unit. So that's what this system will create. And it'll say at that point, hey, the hot water tank is completely and utterly full of hot water. It came to me at 126.5 degrees Fahrenheit. Okay, I can turn off, I can hang out for the rest of the day, or hang out until the tank temperature sensor tells me at another point in time to, oi, get me some hot water, please. So that's the typical setup on these style systems that they will run as they operate themselves throughout the years of operation. Here I just essentially threw out everything I was talking about into a nice thing. So if you download a copy of this particular presentation from eBay, we can get that to you. So when we want to talk about how much hot water does the heat pump make, this is where it can get kind of interesting, because everyone looks at this and thinks, really? That's all? Because we're used to tankless water heaters. You open up a faucet or a shower head, it draws that particular flow through that tankless water heater. You do the same thing on the electric tanks, or even a hybrid tank. You put X amount of hot water into it, the unit will recover that at the mode that it's set up for. This unit, because it's drawing water from the tank that's cold, it will make somewhere roughly in between 19 to 20 gallons of hot water an hour. So if you look at back and we went, okay, well, a typical water size is, tank size is 80 gallons, it would take 4 hours to go from 0 to 100%, 2 hours to go from half empty to half fully full again. So it's all an operational thing. So when anyone sells split systems, whether it's in Japan or it's in Australia or it's in European marketplaces, and certainly I'm sure here in the US, they always look at the recovery rate on these particular systems and how that gets you back to a normal hot water tank that can provide more and more hot water for the homeowner or occupants of the particular home. And obviously, because we're making that type of hot water at 145 or 150, which is very typical for a split style heat pump water heater, then that's going to be able to provide us, or provide the homeowner with a higher volume of water. So every gallon of hot water in the tank at that point in time is roughly about 1.7 gallons at a shower head at 105 degree shower, which is typically pretty normal, or even if you have it in a fixture where you've got a little bit of hot and a little bit of cold in there to reduce it down from 120. So a typical setup on these style systems, and you'll see that mixing valve used globally on these particular split systems live typically, and as what part of what Greg was talking about with ambient temperatures for the systems, and because it can live outside, it does affect the efficiency of units. Any air conditioner or any heat pump that's doing any heating for your home will also do the same thing, and the same would happen again if you had a refrigerator outside. Is the cooler it is, the different the COP level or coefficient of performance is going to be on these particular systems. With these ones, obviously it works a little bit backwards in that the warmer ambient temperature it is, if you said it's today it's 80 degrees outside, the COP suddenly has shot up because there's a little bit more heat to steal from the outside, so that what we see is a COP of 4.5, which means the unit draws around about 800 watts per hour. If we suddenly said, oh, you know what, we've gone into a global cooling world and now it's 14 degrees here, or it's 35 degrees here all the time, you'll see that power draw actually jump up on these particular split style systems, because that will reduce the COP and the unit will consume a little bit more electric energy to drive the compressor and make that hot water that you're using in the home. So it's always a little bit of a up and down and averaging on these types of system. Then obviously that does sort of jump into the good old calculation where we can set up how many gallons does a shower, if you've got 3 showers or whatever going on in the building, and certainly you can do your sizing on these. And again, these would work perfectly on a hybrid style system as well. because it gives you that setup on these heat pump water heaters. So as we've seen, the installation clearances and things like that. Obviously, the one thing that's going to happen with these type of units is that the heat pump lives in a completely different area of the home to the tank. And again, as we said before, it can be significant distance between the tank and the heat pump. And the heat pump on these particular units has been and is globally installed either outside the home, either on an L bracket or on a concrete floor mat, or actually inside of the garage and various places such as that on these particular systems. Now, as you look at those, all three of those particular applications, certainly going to go back and the pipes come out of the heat pumps and off they head off to the particular tank that they are connected to on these systems. And as you can see here, again, looking at another unit sat outside a home on an L bracket, and you can see the piping being created here, and obviously the cold and the hot, as we looked at in the schematics on these particular things, and where you can go with these particular settings, and away you go on these units, and that will disappear inside and go find the tank that this is connected to, with flow from the tank to be heated and the hot water going back to the tank. Then as we look at the various size tanks that you have on here, and again, trying to go a little bit more sort of, small, big, and medium and large on the tanks, just to show that they can all live in the particular areas on here. And really, because of where they're at, you can see that the tank, as it has no power and only has the typically the tank temperature sensor going back to the heat pump, it can live in an area where the actual clearance would be 2 inches. The heat pumps obviously live outside. The clearance on that is about 6 inches to a wall, and then in front is typically a 2-foot length on those particular systems. But you can see the various setups of the storage tank. Wanted to throw in there, and thanks to Greg for that, is that we typically all split style systems are allowable to be used with the recirc setup. And again, I think we all, along with the hybrid gentlemen, certainly prefer your recirc system to have an infrared or some sort of setup, rather than just running all 24/7 or hours and hours and hours, just because they have a timer on these particular systems. So we recommend that being able to walk into the bathroom and turn on your recirc works much better than just running it at all times on these systems. So you can see the differences in the tanks and the setup there, and then you can see as we look closer, this again, a tank living in an unwarmed or cool area inside the home or outside the home, and you can see the 4 connections on the tank, 2 at the bottom, or 1 at the bottom that's shown here, and then one slightly higher up. Again, these are all side style connections, in the tank being seismically secured on these particular units, and away you can go on that. So typically looking at split style units, it's and these setups, are very similar between the manufacturers here in the US and even globally on these particular style systems. Efficiency levels, as you can see, depending on the ambient temperature, the efficiency level goes up and it goes down slightly, but you see that nice high above 2.2 UEF, and the units shown here were actually above 3 on the UEF numbers on these particular systems. As we talked about the performance, the ability, the fact that the unit will always make the high temperature hot water, and that's a very unusual setup for water heaters that we don't normally see, but the recovery rate grows because of that. And then we also keep that capacity, the ability of these units down to run at -26 and even a little bit lower than that still ensures that the unit is creating hot water for you outside of the home, even if we were to all nip up to the coldest place that we could possibly find here in the US. Installation wise, as you can see, it's a little bit different to the hybrids, where the hybrids get a power signal and they're cold in and hot out, and away we go. Obviously, that there is the power required for the heat pump, and then some additional no power for the water connections to the tank that lives inside, the cold and the hot. Mixing valve gets added, and then you have to run the two pipes that go from the heat pump to the tank, whether it's a rectangular EcoCute tank or it's a cylindrical standard US style tank. It always takes two specific cold out, hot in from the heat pump to the heat pump on this. And then last but not least, environmentally friendly, rebates friendly as well. And the carbon dioxide, one of the only very few unique products the split style systems are that will use carbon dioxide to create hot water on these setups. So last but not least on here, as Greg mentioned, he's at Black and White, and I'm with you today, and I'm with a company called Eco2 Systems, or Eco2 Water Heater is the website on these particular units. Pretty much a little bit unique in the only supplier currently the Energy Star approved split style heat pump water heater. Happy to answer any questions. I see that the chat has jumped up, and I have not looked at that, to be honest with you. But thank you all for listening, and I appreciate it very much.
John, thank you so much. I could listen to your accent all day.
What accent?
Yeah, exactly. Quick question. You said freeze protection included. For those of us in the more northern climates where we might have, -15 F outside, how does that work, or what precautions or installation do we have to follow to protect against freezing?
So typically the unit itself has a program internally that essentially does the usual sort of look at. It's like, what's the ambient, what's the ambient, what's the ambient, right? And as the ambient gets colder, it looks at the water temperatures that the heat pump itself has and goes, ooh, getting a little chilly, getting down towards 32. I better run for a little bit, and the unit will sort of kick itself on for about 5 minutes, 10 minutes, and then say, okay, I warmed it up, I win, right? And then go back to sleep and wait for it to come back on that particular operation. And then there are a couple of other additional options that we offer as a company, and those are set up in the one biggest issue that we've always seen is that, well, the freeze protection worked until the power came off the unit because the utility lost all the power to the house because the wire, all the wires froze up or whatever, and then we have some separate style systems. So we've actually looked at that as a 1, 2, and a 3. Versions have been able to do that. So
great, John. Thank you so much. Dean Gamble, I'd love to bring you in to kind of bring us home, or if you have any thoughts to add, or anything directionally of what we might see in the Energy Star certified homes program as far as this technology goes.
I think you'll only see it get more prominent, which is one reason I wanted to hop in on this call. And I work increasingly closely with Nate, just because his product specification is going more hand in hand with the single family new homes and multifamily new construction product specifications. For our core program requirements everyone knows about, it's fuel neutral. You can pick an efficient water heater if you want to, and increasingly to meet our certification, builders are selecting either an instant gas water heater or a heat pump water heater. But we have just been working on the last year a new certification above our core requirements called Energy Star Next Gen that starts to take these steps towards strategic electrification. And that actually requires that a heat pump water heater that's Energy Star certified be used. So it's not for every builder today, but those that are ready to start dipping their toes in kind of what we think is the future of housing, we'll start to look at that spec and see that the future of housing includes a heat pump water heater. So
Dean,
I think
is it not true that you will be presenting the Energy Star Next Gen program at the EVA Summit, September 20th in Scottsdale, Arizona?
That's a good turn back to you, right? Co-promotion here. Yeah, it'll be our first conference actually since COVID hit. So it'll be really great to be back in person with people and talking about this really exciting next kind of forward-looking specification that we think some of the more proactive builders, which tends to be the ebook builder community, are probably ready to step up to. We're really excited about that.
This adds a feature. I always tell builders this adds a feature to the house that the second highest energy user is now Energy Star, and it's saving a significant amount of money. And it's been a hidden feature in the home. People just expect the house to have a water heater. And now when you start showing them you put a water heater in that pays for itself in energy savings, it becomes a part of the model home tour. And I'm probably spending more time with national builders now reviewing those plans specifically for California, because they're making the switch by the hundreds of homes that are going to be built in this fall and also into next spring. So you sure don't want to be, if you've got something on your website that says we build high efficiency homes, and water heating is not an Energy Star water heater, you shot yourself in the foot, because it won't make sense to say I've got great windows and insulation and my HVAC #1 user is Energy Star and my appliances are all Energy Star from my GE days, but we skipped over the water heater. That's where it causes a problem and your program doesn't look as good. So just keep that in.
And I just want to dive into that a little bit more, Dean. There's significant rebates available depending where you live in the country. And I think people can go to the Desire what is it? DSIRE. Help me out.
There's the Desire database, and then EPA maintains its own list of rebates as well that you can check out. And I mean, I think just building off of Greg's point, like when we talk about the future, California is sometimes considered the future, and they're starting to really push from a code perspective. You really need to start thinking about this. And then to your point, Aaron, other parts of the country are really starting to think about the incentivizing of this, because it's just so much more efficient than what you can get otherwise. And,
and then besides the rebates that you can find on the Energy Star website that are available, again, with this new, and I'm going to get the name of the technology, but it's the interactability. It's like our air conditioner today. You can get on a program. You can now do that with a heat pump water heater. You can get on a program. And I've seen in the Minneapolis market where there are preferred utility rates available to people that install heat pumps that bring your savings even further.
Yeah, it's one of the devices in your home that has the most potential benefit for utilities without sort of compromising the performance for the consumers, because it's just a huge thermal battery. They can heat it up at any point, and if it's conducive to doing that, the consumer doesn't care if their water is getting heated up for cheaper. They still get to use the hot water whenever they want. So we think that's one reason that the Energy Star Next Gen requirements will include a connection to port as well, just so that it enables that sort of technology. Doesn't mean the consumer loses control. It just is a feature that enables them to participate in these programs if they choose to. Yeah, and I just want to throw out one more thing. I mentioned California. I would be remiss if I didn't mention Washington State, which is also starting to effectively push builders to use heat pump water heaters. And so it's not just a single state. You're starting to see the most progressive states pick up on this trend already.
Yeah, and again, Maine has done an incredible job on air source.
I know.
on air source heat pump HVAC and on heat pump water heaters. Maine is kicking well above their weight.
They are. I mean, you think about what they're compared to, fuel oil in a lot of cases, or electric resistance is what they've had available. And, this is just, leaps and bounds more efficient than that. So there, especially, you might be dealing with some more challenges because of the cold climate relative to like a completely warm challenge that you might require more thought to installing it. But the benefits are just going to be so tremendous there that it's hard to avoid.
And, the one thing I would add from a Minneapolis perspective is I put my heat pump water heater in. We all have basements up here, which we can argue about if that's a good idea or not. But I was able to now disconnect my industrial dehumidifier that I need to have in my basement. And that thing drew a tremendous amount of energy. So just that free dehumidification in the basement, which we almost need up here year round, is pretty incredible.
Yeah, I mean, that's something that we talk to builders about a lot as well, especially you may not have long-term latent issues, but when you've just built a house and everything is wet and everything is drying out, concrete, the wood, having a built-in dehumidifier is kind of nice. It's kind of like an ideal situation, like you're saying, Aaron. Like, you may not want to invest in a dedicated dehumidifier for the life cycle of the home, but having some dehumidification built in, particularly in the basement where you do have a lot of that wet material, it's kind of nice.
Great.
It's a great byproduct of just heating water, being able to dehumidify and having them in the basement. In your market, that's been always been a big question is, well, is it going to steal the heat from my house? And I always say, if I go down in your basement where your water heater is sitting, what's it sitting next to? What's next to my HVAC? It's in a furnace room. And when I look around, am I going to see vents and returns and a thermostat? No, those are all upstairs. This is an unconditioned space in a conditioned home envelope. That's the coolest part of the house in January and July because it's 8 feet underground. That's free heat. And the water heater says, I can use that free heat. And if I make this space, this 10 by 10 space, 3 to 5 degrees cooler, and you're not sucking it into the HVAC and you're not bumping the thermostat upstairs to turn heat or anything else on, I'm not affecting the performance of the home at all. So the water heater says, I'm using that free heat. And NIA just produced yet another study that I just saw this past couple of weeks ago that showed that the ambient temperature changes that it makes in that room when a water heater runs, and a water heater only runs when you're doing one thing, using hot water, returns back to the status that it was in previously in about 15 to 30 minutes. It's like turning the air conditioner off in your house on a summer's day, or the heat off, and saying, how long is it going to stay warm or cold? Not very long, and it's going to go back to whatever it is around it. So the same thing happens with a water heater. It's not an air conditioner in the house, and it doesn't run all the time. So the only place that it could have any kind of an effect that might be considered negative is if it was on the living space, in a closet, sitting someplace in a bedroom where you say, I feel the cooling effect and I don't like it. That's about it.
Well said. Dean, any last thoughts?
I think this will be just the first of many times we'll be talking with the EBA partners about heat pump water heaters.
We've got a great next session.
Relevant.
We actually have 3 builders from across the United States that are talking about their experience implementing heat pump water heaters. And then we've got several sessions, and we're really proud of our partnership with EPA, Energy Star, and the Advanced Water Heating Initiative, which is where we met all of you. So we'll have several sessions at the EBA Summit on those. So with that, I want to say a special thanks to Nate Jutras and Dean Gamble from EPA Energy Star, of course, Craig Holliday from Bradford White, and John Miles from Eco2 Sanco Systems. All incredible new technologies that everyone should be checking out and seeing how they can get into their high performance homes. Thanks so much, everyone.
Thanks.
Thanks, everyone. Appreciate it.